The scientific method is about ordinary people doing ordinary things. That includes you, me, and other scientists in the world. The scientific method is just a process or steps taken to produce reliable results to answer a specific question. Maybe you think you don't use the scientific method in your life, but I can guarantee that you do. For example, imagine you wake up on a Saturday and you couldn't find your cell phone. That's an observation. Then you do a little research by thinking about the last time you had it. You suspect that it might be in the pocket of your pants from yesterday. That's a hypothesis. And when you check your pants, you're doing an experiment. But science and life don't always go as planned, and you find no cell phone in your pants pocket. So the second observation leads you to think again and recall what else you did yesterday. You remember that you put your cell phone in your backpack during school. So you decide it must be there, and you go and check. And lo, there it is. Life can continue, and you're so happy that you share the results with your best friend and explain why it took you so long to text them back. Science. These are the steps of the scientific method. And at any step, you can go back and repeat the process. Typically, after you conduct an experiment and conclude that your results aren't answering the question, you go back and try something else. And really, truly, observations and research are going on the entire time. Science is a continually ongoing process. Now let's break down each of these steps into their component parts. All that can be observed with the 5 senses are included in observations. You use your sense of smell, sight, taste, touch, and hearing to make your observations in science. Research is an important step in science because it may answer other questions you have and help refine your experiment before you go down a path that leads to nowhere or conduct an experiment that's already been done. Make sure you use reliable sources to learn background information. Scientific journals and online sources that are vetted and trusted are best. Avoid information from blogs and out-of-date textbooks, as the information might not be reliable. Once you have your research completed, you can form your hypothesis, which is a prediction of what you believe will occur. It is often seen as an if-then statement and is very specific. Here's an example. If gummy bears are placed in water for 24 hours, then they will swell to over twice their original size. It has an if and a then, and uses specific terms that make this experiment repeatable. The experiment itself is made of several parts. Most experiments collect 2 types of data, qualitative and quantitative. Qualitative data relies on descriptions like soft, yellow, shiny, or wet. Quantitative data relies on numbers like 25 centimeters or 2.3 grams. Once you know what types of data you're going to collect, you can define the variables in your experiment. There is the independent variable, which is the thing you change to see how it affects your dependent variable, which is the thing you measure. So in the gummy bear example, the change in the experiment is that the gummy bears are being placed in water. The dependent variable is the volume of the gummy bear, which is measured before and after it's soaked in the water. A valid experiment will have both an experimental group, where the independent variable is altered, and a control group, which can be used to compare the experimental group to the normal or unaltered version. In the gummy bear experiment, the bears placed in water are the experimental group, and the dry gummy bears are the control, because that's how gummy bears normally are. So to summarize, an experiment should have an experimental group and a control group. The experimental group will have an independent variable and a dependent variable, and the data that is measured and collected can be qualitative, quantitative, or both. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe, and follow me on Twitter @SciencePet.